The aim of the experiment is to measure the voltage on the primary and the secondary side of the three-phase transformer for different configurations. Okay, so the apparatus required is three-phase 2 kVA transformer, N1 equal to N2. Okay, that the transformer has two windings, one is primary winding and one is secondary winding. So let these windings be N1 and N2. So if N2 is more than N1, then it is a step-up transformer, and if N1 is more, then it is a step-down transformer. Okay, and if the number of turns of the transformer are same as in this case, you can see, so then it becomes auto transformer. Okay, so auto transformer configuration exists in single phase transformer as well as in three phase transformer. Okay, so so we are having the 2 kV transformer with the primary windings and secondary windings same. Okay, so here the there will be no change in the ratio of the voltages due to number of turns. Okay, so in the this is the three phase transformer. So in the auto transformer, the part of the primary winding is also associated with the secondary winding. Here it is not a auto transformer, it is a transformer, but the number of turns of the primary winding and secondary windings are same. Okay, so the electrical panel is required in which this transformer is there, which is fitted with three phase supply, and three phase auto transformer is connected to this supply system. So what is the role of the three phase auto transformer? It ensures that the desired voltage is fed to this three phase 2 kVA transformer. So we have studied two types of three phase connections. One is star connection and one is delta connection. So this star or delta connection can be applied to the primary side or to the secondary side. Okay, so based on this, we have four possibilities that the three phase transformer is either star star connected. So when it is star star connected, it means that the primary side is also star connected and the secondary side is also star connected. How we are required to physically connect these configurations, that can only be done with the help of the wires and at the lab. But here what we will do, we will try to understand what can be done and what are its advantages and applications and what are its possible outcomes. Okay, so first is our star star connection. So you can see the diagram of the star star connection. So the primary side is denoted by small letters and secondary side by capital letters. Okay, so load is connected to the secondary side. Okay, so and these voltages which we are talking, these are in the primary side where it is denoted as VAN. So here we are taking the voltage per turn of the phasor quantities, phase voltage, and this VAN upon VAN is equal to N1 upon N2. So when these N1 and N2 are same, so this phase quantity becomes same. Okay, but similarly the line voltages on the both these sides are also same. It is not a problem. Okay, so VAB with AB as small letters is when they are taken the ratio with VAB of the secondary side, which is the load connected side. So it is the ratio of the line voltage, and line voltages are root 3 times the primary voltage, phasor voltage. So it becomes root 3 VN and root 3 cancel out each other. Okay, so this is the situation. So so these one is the primary system, and so in the transformers, the representation we have studied that we are connecting like this. Okay, in the practicals you have studied this. Okay, so this is the representation of the single phase system, and similarly we can do for the three phase system. In the three phase system, this winding will be three windings will be there. Let us suppose we are talking of the primary side, which is star connected. So in the star connected, what is happening? One terminal is connected to the phase and other is connected to the neutral, this neutral. So all these three phases are connected to the neutral. Okay, so these are our three terminals of different phase. These are all connected to the same neutral, and so this is the A phase, and all the other terminals are connected to the three different phases like this. Okay, so ABC, this is the three phase connection diagram of the star system in the primary side. Okay, so similarly we can draw the star star connection on the secondary side. What we have to do, since this is a three phase transformer, this is induction is this, and coils are represented like this, and similarly like this and this. So, and again they are connected to the common neutral and so on, and different phases. Okay, but what is happening here? So these are connected to the supply system, and these three phases on the secondary sides, they are connected to the star load. Okay, okay, so now things are clear. It must be clear to you. So in the star connection, we know that the phase voltage is reduced by root 3. Hence, less number of turns are required. If the current passing is less, then the less number of turns are required. And also we can use the conductors of less thickness. Okay, so these are used pretty advantage for the small high voltage purpose, in which the magnitude is more and the size of the transformer is small. And so the this phase voltage is root, but the in the star connection the current is same. Line current is equal to phase current. So whenever, so it will carry the high current. So whenever there is high current, there will be a windings will be of higher thickness. So it is neutral is also there, so it is suitable for three phase four wire system. Okay, so three phase four wire system is existing in our distribution level as well and transmission as well. Okay, so these star star connections are used for interconnection of system, one substation to other. Okay, one transformer is connected to the other because of the variable voltage which we can achieve and receive because of the availability of different number of turns. Here for our convenience we have taken this as same. Okay, but in the reality these n1 and n2 are different. So the four systems which are operating at 800, 440 volts, 220 volts and 66 kilovolts, they can be interconnected using this kind of arrangement. Okay, that when we are drawing this diagram, we are using three different colors: blue, black and red. Okay, so these represent three different phases, and dot is there. Okay, dot means that the phases of similar polarities are to be connected alongside. Okay, we have just drawn the diagram using the coil system. Okay, so the R phase of the primary side should be connected or shown. What should be shown below it? The R phase or the A phase of the secondary side. Okay, so it is representing that. This is showing the polarity. So in the star delta connection, it is advantages for large high voltage step down power transformer. Okay, so here the primary side is star connected and secondary side is delta connected, and it can handle the unbalanced load also. Okay, so when we are talking of the unbalanced load in the transmission lines, when we are talking about transmission lines from the sending end to receiving end, no load is connected. Okay, so when no load is connected, the system is balanced. So in this star delta connection, it can handle the large unbalanced loads as well. Okay, and it is used in the high voltage step down transformer. High voltage is being received from the transmission line, and at the substation these are step down. Okay, so its applications are at the end of the transmission lines. Okay, and it is used in the step down transformer. Okay, so star connection on the high voltage side reduces the insulation cost, and the neutral point on the high voltage side can be grounded. Neutral point can be grounded. Okay, so this is the connection diagram. Advantages and applications are already discussed to you. So it is like any other star connection. RYB phase are shown, and similarly on secondary side, delta connection is shown. Okay. Now is the when we are doing this experiment in the lab, what we do, we set voltage with the help of auto transformer, okay, and measure the voltage, these line voltages, physically using the voltmeters which are connected to the panel. Okay, so what we do, we measure these voltages physically as well, and also based on the voltage which is given to us, we calculate its value numerically. Okay, then we can compare what is going on, whether there is some minor difference or not. Maybe the error of 1%, 2% is permissible. Okay, so this is what we do and verify in the lab. So next is our delta star connection. Primary side is delta and secondary side is star. Okay, so what happens in the uh, star connection, we have already studied in, and or what happens in the delta, this is also we have studied, although you might not be remembering the results which we have already studied. So I have told you that the when we are doing the connections on the delta side, the line voltage is root 3 times the phase voltage. Okay, so this is our phase voltage, I by root 3, and this I is our line voltage. Okay, so and in the star connection, line voltage is root 3 times phase voltage. Okay, so this is one phase, any phase you can say, it is R phase, this is neutral, so voltage between them is V. Okay, but if its transformation ratio or turns ratio, which you can say, is A, then its voltage is reduced to V by A. Okay, so this is the phase voltage, and this, the voltage between the two phases is root 3 times the phase, so root 3 is multiplied by this phase voltage and it becomes root 3 V upon A. Okay, so this is the physical magnitudes of the voltages. So in this delta star, again, it can handle the unbalanced load without any problem, and its applications is distribution transformer. Okay, with the delta in the primary side and load is connected in the secondary side. So this is the distribution, it is using the distribution transformer. Okay, so the distribution transformer of any big society, it is applicable, and so different phases are given at different blocks, or even at on the same home, same house, different phases can be given. Okay, so that is given using this distribution transformer with the star connection in the secondary side. Okay, so different loads are connected in this phase, R phase, or some load is connected in the Y phase, some is connected in the B phase. So if at all one of the phase goes out of the operation, still these two are operational, so it will serve the purpose. Okay, so last is our delta connection, although it is not very popular. uh, so it is advantage of this is the, in order to get the secondary voltage as sinusoidal, the magnetizing current of the transformer must contain the third harmonic component. Okay, so we know that the current carrying conductor produces a magnetic field. So but the iron or the magnetic parts or the ferromagnetic parts do saturate. Okay, but our aim should be to avoid that saturation of the transformer. To avoid that saturation, what we do, we provide the current. Okay, and that current is called exciting current. So why it is exciting current? Because it excites the transformer. Okay, otherwise, you know from the hysteresis curve that the if we are dealing with any, and this BH curve, you know, so what happens, initially it is good linear relationship between the B and H is there, but a point come when it saturates. Okay, so to take this ferromagnetic material out of saturation, what is done, a current is supplied, because current carrying conductor produces a magnetic field, so it will provide the necessary, generate the necessary magnetic field. Okay, so this exciting current which is operating at no load. Okay, it is immaterial whether the load is connected or not, but because this current is operational even in the no load condition or I naught condition. So it is having two components. Okay, so one is the magnetizing component and other is the core loss component. Okay, so this is the magnetizing component. We will learn more about it in the next unit. So this is the magnetizing current of the transformer, and for the effective operation it should have the third harmonic component. Okay, so okay. So the delta connection provides the closed path for the circulation of the third harmonic component of the current. Okay, which is helpful because delta connection, you know, it is having the closed path on the both primary side and secondary side. Okay, okay. So it is suitable for large sized but low voltage transformer, and it is used in industrial applications to reduce these SLG faults on the primary system. What is this SLG? SLG is single line to ground fault. Okay, different types of faults occur in the supply system. So this is a single line to ground fault. Okay, so its connection diagram is already explained to you. Procedure of connecting these wires. I am skipping this because we are not doing this experiment physically. So in the observation table also, what we do, we supply the different voltages and record the voltage from the voltmeter here, and by calculating these values we write here. Okay, and rest is the precautions that the connection should be tied and you should not touch the insulated wires and so on for the safety measures.